So I was getting ready for my lecture to do the review for the second test here in Math 142, and I'm a bit concerned that the review is longer than I could do in a class period, so I decided to just sit here and record a video so that at least you could have something you can watch at home just in case I can't get this done. I should probably trim this and make it a little bit shorter to make this review something I could do in one class rather than something that might take an hour and a half to do. So I'm going to sit here and do this by myself. There's nobody in the room. There's a reasonable chance that I make a mistake somewhere. So if you're watching this and you swear that your answer is right and my answer is wrong, there's a chance that that's the case. Let me know, and then I'll read you the problem. So the first question wants me to find the area of a triangle, and it's really nice. It gives me that the base, even though it doesn't call it the base, is 7 centimeters, and it tells me the height, it actually draws it out for me, is 6 centimeters. And to do the area of a triangle, it's half the base times the height. So this is going to be 1/2 times 6 centimeters, or 7 centimeters times 6 centimeters. Units are important, so I'm keeping my units here. I know that area needs to be square units, so my answer is going to have a square centimeter. I can use my calculator to do this, and I probably can do it without a calculator. I could just do the 7 times 6 first and then take half of it. So without my calculator, I'd multiply the 7 centimeters times the 6 centimeters and get 42 square centimeters. Half of 42 is 21. I certainly could have done this on my calculator. Could have went 1 divided by 2 in a parentheses times 7 times 6. I can't put the units on my calculator, but I certainly could have done parentheses 1 divided by 2 times 7 times 6, and it would give me the 21 the same way. So 21 is the number that I need. The units that I need are square centimeters because I'm multiplying centimeters times centimeters. That's a friendly problem, hopefully. There's a lot of friendly problems and some harder problems, just too many problems, I think. The next picture is problem 2. Problem 2 wants me to find the perimeter of this figure, and then problem 5 relates to this shape. It wants me to find the area. So I'm going to do problems 2 and 5 simultaneously. So problem 2 wants the perimeter of this figure. To find the perimeter of any figure, I add up the length of all of its sides. And for this particular problem, the sides that aren't labeled, I have assumed sides. The side across from the 17 is supposed to be another 17. The side across from an 8 is supposed to be another 8. The perimeter, which I write with the letter P, is just going to be the sum of each side. It's a 17 feet plus an 8 feet plus a 17 feet plus an 8 feet. That's just taking each of the sides and adding them. You could do 2 times 17 plus 2 times 8. That's twice the width plus twice the length, if you remember that formula. I'm going to write P for perimeter. When I'm adding, I'm not getting square units. The units are just going to stay feet. And then when I add the numbers, 17 plus 8 is 25. 25 plus 17 is 42, plus 8 is 50. And the answer, the perimeter of this is 50 feet. That's the answer to number 2. Simultaneously, I'll do problem 5, which asks me to do the area of this. I went through and typed all the area formulas up. They're not on your review, but I typed them up so I could have them at my fingertips. And the area is the length times the width. The length is usually the longer of the two sides. In this case, the 17 is going to be the length. It's in feet. The width is going to be the shorter of the sides. It's 8 feet. And when I multiply these to get the area, I'm multiplying feet by feet, so I'm going to get square feet. I can write square feet or write 2 for an exponent. And then I'll multiply 17 times 8. And I just did 17 times 8 in my calculator, and I got 136. So the answer to number 5, the area of that rectangle is 136 square feet. The answer to number 2, the perimeter of the area of the rectangle is 50 feet. So I'm going to probably do 3 and 6 together and 4 and 7 together, because 3 wants me to find the perimeter of this parallelogram, and 6 wants me to find the area of the same shape. So to do the perimeter, which is the actual number 3, I'm going to add up the length of the sides. This 4, that's a height. That's not one of the sides. That's a number that's needed for the area, but not for the perimeter. I need to match up the sides. The side opposite the 11 is still an 11. The side opposite the 6 is still a 6. I'm going to write P for perimeter. Then I'm going to add up the sides. It's going to be an 11 centimeters plus a 6 centimeters plus an 11 centimeters plus a 6 centimeters. When you're adding, the units don't become squared or cubed, so it's just going to be centimeters. 11 plus 6 is 17, plus 11 is 28, plus 6 is 34. The perimeter of the area of the parallelogram is 34 centimeters, not centimeters squared. Problem 6 wants me to find the area of this figure. The area formula is the base times the height. The height is given at 4 centimeters. The base is the side where the height connects with. In this case, the base is going to be 11 centimeters. The area of this, I take the base, 11 centimeters, times the height, that's 4 centimeters. Multiplying 11 times 4, I get 44. Multiplying centimeters times centimeters, I get centimeters squared. So the area is 44 square centimeters. So that's problems 3 and 6 simultaneously. 3 wants me to find the perimeter of that parallelogram. 6 wants me to find the area. When you're watching my videos, probably the very best thing you can do is right before I do a problem, if you haven't worked it out, work the problem out first and then watch the video to see if you match up with me. That's the best way to know that how much you do or don't understand. Just watching the video without having the problem worked out ahead doesn't really test you to see how well you know this. And because this is a review, in theory, you should be able to do all these problems. I'm sure that, there's going to be problems you don't remember how to do, but a lot of the problems hopefully you can do before watching me do it on the video. So the next problem is problem 4. It wants me to find the perimeter of that trapezoid, and then I'll find the area. The sides are just kind of messed up. I really feel like changing the lengths because this 18 is shorter than the 25s, but I'm just going to live with it. The numbers I picked for the sides of the trapezoid are bad. This 2 feet right here, 2 feet times, I need to change it to inches. I multiply by 12 to get feet into inches because 12 inches is a foot. And so this 24 is, looks shorter than that 18. So the sides are a little bit messed up, but nevertheless, even though the lengths don't really maybe work perfectly, I can still answer the questions. The perimeter is just the sum of all the sides. The height isn't a side, it's just that dashed line isn't a side. The perimeter of this trapezoid, I'll write P equals to 5 inches plus 25 inches plus 18 inches plus 25 inches. I'm just adding up the length of each of the sides, and hopefully I can do this. 5 plus 25 is 30. 30 plus 18 is 48. Plus 25 is 73. So I'm going to say the perimeter is 73 inches, and I'm not going to get square inches. So that's the answer to problem 4. It wants me to find the perimeter of that figure. 7 wants me to find the area, and I wrote the area formula for a trapezoid down just because I don't have it memorized. This should be a test that you're allowed to use a note card on, and you should get me to tell you which formulas you absolutely need for the note card so you don't have to load your note card up with things that you don't need. For this particular formula, I need to have the height and the bases. The height is this dashed line in the middle, which is 24. I changed it to inches. If I left it at feet, I'm going to get the wrong answer because my units need to match up. And the bases are where the height connects into. The bottom base I call the base 1, and the top base I call the base 2. So for this particular problem, into my formula, I'm going to plug in 18 inches for base 1. I'm going to plug in 5 inches for base 2. And then inside the parentheses, I go 18 plus 5 gives me 23 inches over 2 times 24 inches when I do the multiplication, I have an inch times an inch, and when I multiply inch times inch, I get an inch squared. So area is going to be square units. My units should be inch squared, and I need to go 23 divided by 2 times 24. I'm going to break my calculator out to do that. I can do it without my calculator, but it's safe to do it on my calculator. I'm going to put the 23 over 2 in a parentheses, then multiply by 24, hit enter, and I get 276 square inches. Generally, the area is a considerably bigger number than the perimeter. So the answer to number 7, which is the sister problem to number 4, using the same figure once the area as opposed to the perimeter, is 276 square inches. Eight and 9 are supposed to give me a circle. This is a circle with a diameter of 6 centimeters. So this is not a sphere, it's a two-dimensional circle. It has a diameter of 6 centimeters. If I divide the diameter in 2, it means it's going to have a radius of 3 centimeters. A radius is always half a diameter. And problems 8 and 9 refer to this circle. Problem 8 wants me to find the circumference of the circle, and it wants me to write the units down. And I wrote the formula down that I was going to need because I wasn't sure if I was going to remember it. So the circumference formula, I should write a C here as opposed to an A. The circumference is 2 times pi, and for our test we're going to use 3.14 for pi, times the radius, and the radius is 3 centimeters. When I multiply these, there's only one unit, so I'm not going to get a square unit. I'm just going to get centimeters. And all the problems on the test, I'm going to round to 2 decimal places, and I'm going to use 3.14 for pi. So anywhere on the test, if you use 3.14 for pi, and if something has more than 2 decimals, if you round to 2 decimal places, that's going to be consistent with what I do, so that would be nice. So the answer to the circumference is 18.84 centimeters. It's not centimeters squared because there's only 1 centimeters that I'm multiplying. I'm not multiplying centimeters times centimeters, so I don't get centimeters squared. Problem 9 refers to the same circle. It wants me to find the area. The area is pi r squared. And in for pi, I'm putting 3.14. In for r, I'm going to put in 3. And it's 3 squared. It's really 3 centimeters squared. So technically, the area is 3.14 without units times 3 centimeters times 3 centimeters, because squaring means to multiply by itself. When I multiply the centimeters times the centimeters, in my answer I'm going to get centimeters squared. And then I need a number. I'm going to round it to 2 decimal places. This might only give me 1 decimal. So I'm going to go 3.14 times 3 times 3. And I get 28.26, and then square centimeters. So the answer I'm going to write down for number 9, the area of that circle that has a diameter of 6 centimeters is 28.26 centimeters. I use the radius formulas for both the circumference and the area. The circumference has a formula that you could have used the diameter, but I needed to find the r, so I used the formulas for the r's. The units are important. Circumference doesn't have a square, area does have a square. 10, 11, and 12 all relate to this triangle. This triangle is a right triangle, and a right triangle because it has a right angle. The side opposite the right angle is a C, and the other sides are interchangeably A and B. For this problem, I'm going to say the A is 5, the C is 13, and I'm going to solve for B. Means I'm going to need to do some square roots to do this. I'm using the A squared plus B squared equals C squared formula, which is a Pythagorean theorem. I'm going to plug in 5 for A and square it. I'm going to leave the B with a squared, and I'm going to change 13 to C and square it. To do the squaring, 5 squared is 5 times 5, which is 25. B squared, I don't know what it is. I'm going to leave it at B squared. 13 squared is 13 times 13 is 169. I need to solve this for B, so I'm going to minus 25 from both sides, and then I'm going to take the square root, because I want to know what B is, not in B squared. If I subtract 25 from the left side, I get B squared. If I subtract 25 from the right side, 169 minus 25 is 144. And then if I know what b squared is, to find out what b is, you take the square root. The square root of b squared is just b. The square root of 144 is 12. And so this b equals to 12. All the sides are in meters. I forgot to put my meters down, but I'm going to put my meters there. Technically, I'd get square meters, and then square rooting square meters, you'd get regular meters. But I'm just going to, because it's the length of a side, I know it's not square units. So the missing side, if I called it A, would be fine, but it's 12 meters. Now I'm going to answer the next question to find the perimeter of this triangle. To find the perimeter of any triangle, you add up the lengths of all the sides. The sides of the triangle are the 5 meters and the 13 meters that I knew to start and the 12 meters that I just figured out. When I add up meters plus meters plus meters, I don't get square meters, I just get meters. And when I add up the numbers 5, 13, and 12, I get 30. The perimeter of that triangle is 30 meters. So that's the answer for 11. And 12 still refers to this triangle. 12 wants me to find the area of this triangle. To find the area, I need to know a base and a height. There's a right angle. And the side that's connected to the right angle is going to be the base. So I would call this side the base and this side the height. The 13 isn't a base or a height because it's not at a right angle to the height. So the area is going to be 1/2 the base times the height. The base is 12 meters. The height is 5 meters. I'm going to do half of 12 times 5. I'm going to do the 12 times 5 first. 12 times 5 is 60. Meters times meters is meters squared. And then half of 60 is 30. So the area for this particular triangle is 30 square meters. (13) is a shaded area, and it's kind of a hard shaded area. What I'm supposed to do, realize is that this is a square that's 10 units on each side, although it's kind of hard for me to show using Excel, apparently, or Word, should I say. I have a hard time getting these arrows right. So this is supposed to be a square that has a side of 10, and inside it is a circle, and the circle, its radius is halfway across the square, so it's going to have a radius of 5. I should probably get some units. And these are all meters. So in each of my 10, it represents a meter. The 5, that's the radius, represents a meter. And the shaded area is the area of the big square minus the area of the circle. So these little regions here, to find these areas, it's deleting the circle's area from the square's area. So I decided that I was just going to find the area of the square, which is 10 meters squared, minus the area of the circle, which is 3.14 times 5 meters squared. So this is going to be 10 meters times 10 meters minus 3.14 times 5 meters times 5 meters. This is 100 square meters minus, can't do this without a calculator, minus 78.5 square meters. When you subtract square meters minus square meters, you get square meters. So I'm going to take the 100 square meters minus the 78.5 square meters, and I get the area, the shaded area, is 21.5 meters squared. In class, I did a lot of problems by just using my calculator to do the entire computation. That's completely fine. If you've written down this is what I needed to solve and wrote down the answer without showing the intermediate steps, that's completely fine. If you make a mistake it makes it easier for me to figure out where to give you partial credit if I can find out where you made the mistake. Like, did you write 10 there instead of 100, or did you make the wrong part there? The more work you show, if you have a wrong answer, the more partial credit you're going to get. The less work you show, the less partial credit you're going to get. The next problem, for me, is worded kind of tricky, and I had to understand the question before I could actually answer it. Again, it's a shaded area, and to do it, I needed to find the shaded area I want is the area of the big circle minus the area of the small circle. The big circle is easy. The big circle has a diameter of 6 centimeters. It has a radius of 3 centimeters. That I can get just by looking at the picture. That 6 is supposed to be the diameter of the big circle. To get the diameter or the radius of the small circle, I needed to read what was given to me. And this said the larger circle has a radius 1 centimeter larger than the inside circle. So the inside, or the smaller circle, has a radius that's 1 less. Its radius is going to be 2. Because for the bigger circle to have a radius that's 1 more than the little one was 2, 1 more than 2 is 3. So I had to read the question carefully enough to realize that for the larger circle to have a radius 1 more than the smaller, if the largest radius was 3, the smaller would have to be 2 for it to be 2, 1 more than 2 is 3. Now that I have the circles understood, I know the bigger circle's radius, I know the smaller circle's radius, I understand visually I'm trying to find the area of the big circle minus the area of the small circle. I'm going to plug my numbers in. The area of the big circle is pi r squared. Its r I put as a big R because it's a bigger circle, so it's 3.14 times 3 centimeters squared. The area of the small circle is 3.14 times the small r, which is 2 centimeters squared. I'm going to do this all on my calculator, I think, and cheat. So I'm going to go 3.14 times 3 centimeters times 3 centimeters minus 3.14 times 2 centimeters times 2 centimeters. The units here are centimeters squared. The units here are centimeters squared. My answer's units are going to be square centimeters. And on my calculator, I'm going to go 3.14 times, and I could do 3 squared, hit 3 and then just hit my squared key, and then minus 3.14 times, I can go 2 times 2, I could have done 2 squared. And then when I do these and I hit enter, I get 15.7, and the units are going to be square centimeters. So the region that I'm worried about has an area of 15.7 square centimeters. So this is the area of the shaded region. I can't imagine putting something that hard on the test, but it's on the review, so wouldn't be illegal for me to put it on the test. I just kind of surprise myself if it's actually there. 15 asks me to find a volume of a box, and I have to understand that a box is the same as a rectangular solid. And so I snuck the volume formula for a rectangular solid that looks like a box to me. It's length times width times height. And all of a sudden I don't see those words. So for this tall, I'm going to consider that the height. For the wide, I'll consider it the width. The deep, I need to consider it one of the things. Since I already have the width done and the tall for the height, I'm going to call the deep the length. So I'm going to use the formula. The volume of a box is the same as the volume of a rectangular solid, and the volume is length times width times height. I decided to make 24 inches. Those two lines are inches. Those two little apostrophes, I guess. So 24 inches times the length, and 24 inches times is the width, and 40 inches is the height. My units are inches times inches times inches, which is cubic inches. So I'm going to write inches cubes. I could have written the word cubic inches. And then the number is going to be rather large, so I get my calculator, go 24 times 24 times 40. and I get 23,040 cubic inches is the volume of that box. "16 talks about a play pool. That's, again, it's kind of the shape of a rectangular box. This pool isn't a round or an oval pool. It's just 24 feet long, wide, 18 feet wide. In the deep, since I have a length, I have a width, the deep part is going to be the height for this. So this pool is 24 feet long, 18 feet wide, and 4 feet high. Ask me how many gallons of water can it hold, and I see the relation that 1 cubic foot of water is 7.5 gallons. I need to first figure out the volume of the pool in cubic feet. The volume is the length, which is 24 feet, times the width, which is 18 feet, times the depth or the height, which is 4 feet. When I multiply those, feet times feet times feet give me cubic feet. And then I multiply the 24 times the 18 times the 4. The pool has a volume of 1,728 cubic feet. That's not the answer to the question, but that's the beginning of getting to the answer, because it wants me to know how many gallons it would hold. And I have this relationship between cubic feet and gallons, and I'm going to use unit analysis. I'm going to take the 1,728 cubic feet, that is the volume of the pool, and I'll multiply it by the unit. 7.5 gallons of water is the same as 1 cubic foot of water, using the notation for cubic foot rather than writing out the word. I'm going to cross out the cubic feet. When I do unit analysis, I put in the bottom what I'm trying to get rid of, in the top what I want. I wanted gallons, so I put those up top. Want to get rid of feet, I put those on the bottom. The numbers now are on the same level, so I'm going to multiply them. 1728 times 7.5, and I get 12,960. The units are gallons. The only units left here is gallons. So this pool is 12,960 gallons. I think that seems reasonable. I think that's a reasonable amount of water for a pool. "17 is 3 different volume problems in one, and I don't know how well these actually show up. The first one is, the first picture is a cylinder, and for this cylinder, it has a radius up top that is 4 inches, and it has a height that's 12 inches. I need the volume formula for a cylinder, which again, I didn't have known. I just picked it off here. Volume is pi r squared h. For pi, I'm plugging in 3.14. For r, I'm plugging in 4 inches. For h, I'm plugging in 12 inches. So technically, the volume of this cylinder is 3.14 times 4 inches times 4 inches times 12 inches. Inches times inches times inches are going to give me cubic inches. And then when I multiply the numbers out and round to 2 decimal places, I go 3.14 times 4 times 4 times 12, and I get 602.88. So for the cylinder, its volume is 602.88 cubic inches. The next figure is a rectangular box. And it looks to me like it has 3 lengths. This I'm going to call the height. And that's going to be, looks like it's 0.25 inches. I kind of wrote over it. Hopefully that is what it is. This I'm going to call the width. It turns out really not to matter exactly what you call the sides. And this I'm going to call the length. It doesn't matter. You're just going to multiply the 3 sides of a rectangular solid to get its volume. It doesn't matter what you call each. So I'm going to go volume is 2 inches times the width, which is 1 inch, times the height, which is 0.25 inches. My units are inches times inches times inches, so that's cubic inches. And then I multiply 2 times 1 times 0.25. I think I can do that, but I'm afraid that I'd mess up. So I'm just multiplying on my calculator, and I get 0.5 cubic inches. The next figure is a square. or cube, should I say. It's also a rectangular solid. I could call one of the 10s a height, one of the 10s that's not written a width, and one of the 10s that's not written a length, and just do the formula for volume like I did the box here. Or I can use, because all the sides are the same, the volume for a cube is just the side cubed. In this case, its volume is going to be 10 inches times 10 inches times 10 inches, which is the same as L times W times H if you made each side have a name. And when I do this, inches times inches times inches are cubic inches, and 10 times 10 times 10, which is what 10 cubed is 1,000. So the volume of the box is 1,000 cubic inches for the third figure in problem 17. There aren't any surface area problems on the review, so there must not be any surface area problems on the test, so I won't worry about those. 18 gives me a pyramid with a triangular base. And for the area of any pyramid, the volume of any pyramid, a pyramid, the volume is 1/3 times the area of the base times the height. So I need to understand, even without the picture, what I need to get for the volume. I need to know both the area of the base and the height. And in this problem, it says, if I read through it, it says the base has an area of 12. That's written horribly. It should probably be 12. Oh, all measurements are in inches. That should be 12 square inches. So the base has an area of 12. I'm implying because the measurements are in inches, it's going to be 12 square inches. And it says the height is 16. I'm assuming that's also in inches. It gives me an extra number 38. That 38, I don't need to find the volume of a triangular pyramid, because, or just a pyramid in general. I wouldn't even have to call it a triangular pyramid, but a pyramid in general, the area is 1/3 of the base times the height, the area of the base times the height. So the volume here is going to be 1/3 times the area of the base, which is 12 inches squared, times the height, which is 16 inches. When I look at my units, I'm multiplying square inches, which is inches, times another inch. I'm going to get cubic inches. So for my volume, my units are the square inches times the linear inches, which are cubic inches. And now I'm going to multiply these numbers out. Notice I just put the 12 in. I didn't go 12 times anything, because that is the whole area done for me. So I'm going to go, my calculator, I'm going to go parentheses 1 divided by 3 times 12 times 16, and I'm going to get 64. So the volume of this particular pyramid is 64 cubic inches. Seems like a pretty tricky problem. I don't remember doing one exactly like that in the homework, but I didn't do all the homework. I just assigned the homework, so maybe there was one snuck in there like that. But I have to understand that the volume of any pyramid is 1/3 times the area of the base times the height. I gave you the area of the base without the units that I should have put on there. I gave you the height, and I gave you the perimeter, and that perimeter was kind of extra information that is going to not be used in the computation. 19 wants me to find the volume of a sphere with a diameter of 20 centimeters. I plugged off the formula for the volume of a sphere, which is 4/3 pi r cubed. R stands for the radius. If the diameter is 20 centimeters, the radius is always half of that, so the radius is going to be 10 centimeters. So the volume for this sphere that's described is going to be 4/3 times 3.14 for pi times r cubed, which is going to be 10 centimeters cubed. If I want to write it without the exponent, this is 4/3 times 3.14 times 10 centimeters times 10 centimeters times 10 centimeters. I probably should have had a parentheses here. The units are going to be cubic centimeters, because if I multiply centimeters times centimeters times centimeters, I get cubic centimeters. And I'll do this on my calculator in one quick computation. I'll do the fraction 4 divided by 3 in a parentheses, and then times 3.14 for pi, and then times 10 times 10 times 10 to cube the 10. And when I do this and hit enter, I have to round this, and I'm going to get 4186.6. The number in the second position is a 6. It needs to be rounded up to a 7 because the number in the third position is 5 or bigger. It's a 6, so I need to round up. So 4186.67 is where I need to be for the volume of that particular sphere. 20, I'm getting into Roman numerals, and I didn't remember my Roman numerals as well as I should. There's the handout that gives us the special Roman numerals that I'm always on the lookout for. I'm looking for IVs, IXs, XLs, XCs, CDs, and CMs. If I don't see any of those, I'm doing well, but if I do see those, I have to worry. So for this particular problem, I see a C that I can leave alone. The XL need to be bound together in the V. The C stands for 100. The XL that needed to be bound together stands for 40. And the V, which was allowed to be written by itself, stands for 5. I'm going to just add up those numbers, and I'll get the regular number for the Roman numeral. It's going to be 145. 20b, I don't see any of the special symbols. I don't see, an XL or a CD or a CM. There's no special symbol, so I just write down what each letter means. M means 1,000. V means 5, and I add the numbers 1,000 plus 5, and I get 1,005. So the answer to 20b is going to be 1,005. Too many Roman numerals. Part C of number 20, the thing that needed to be kept together was the XL. So when I started writing these out, I didn't get all the way complete. For each M, those are 1,000. So I'm going to keep the M separate and write them each as 1,000. The C, because it's just a normal C, is 100. The XL needed to be bound together, and those are a 40. The V is a 5, and the I after the V is a 1. Now that I've separated all the Roman numerals into the pieces they're allowed to be separated in, the XL needed to be bound together, but anything else that wasn't a special could be written separately. I write the numbers for each, and I add these up. This is going to be 2,000, that's 2,100, and that's 46. So the part C is 2146. Did a similar activity for part D. Part D had two special symbols. It had a CD that on my little chart tells me that it actually has three special symbols. CD is equal to 400. XL is equal to 40. And this IV is equal to 4. So when I write this problem down, the pieces that can be written separate are the three M's. The CD need to be tied together because they're in that backwards order. The XL and the IV need to be targeted together. Each of the M's, there's three of them, each stands for 1,000. The CD you should have on your note card is 400. The XL that should be on your note card, that's 40. The IV should be on your note card, that's 4. Add these up, 1,000, 2,000, 3,000, 444. I believe if I broke out my calculator and added those up, I'd get 3,444 for the Hindu Arabic version of that Roman numeral. So when I'm writing something from a Roman numeral into a Hindu Arabic number, I just take each letter and write it separately unless it's one of my special letters. The special letters are IV, IX, XL, XC, CD, and CM. If those letters are written in that order, those letters need to be kept together, and underneath them I write, 49, 40, 90, 400, or 900. Anything with a 4 or 9 is special in Roman numerals. The next problems want me to write numbers as Roman numerals, and I need to break each number into its, thousands, hundreds, tens, and ones, and fives and ones. For 45, I'm going to think of 45 as its tens, which is 40, plus its fives, which is 5, and it doesn't have any ones, so I'm not going to worry about it. 40 is the special symbol, it's XL. So in for the 40 part of this, I'm going to write XL. In for the V part of this, I'm going to write V. So it's just going to be XLV. For part B, 394, I think of that as 300 plus 90 plus 4. 300 is just 3 C's, so I'm going to write a CCC for the 300. 90 is a special one, as well as 4. 90 is XC, 4 is IV. So in for the 90 part of this, I'm going to write an XC, and in for the 4 part of this, I'm going to write an IV. So 394 should be CCC, XC, IV. There's the 300, there's the 90, and there's the 4. C wouldn't be on the test because it has a bar. There's no problems on the test that need a bar. But 4,000 is not something I can do with M's. I'm not allowed to write 4 M's next to each other. Thousands normally have M's, but once you get more than 3,000, you need to get bars. To get 4,000, I need a 4 with a bar over it. And 4 is IV. It's a special symbol. A bar over it makes it a 4,000. A 70, which is the 10 part, is 50 plus 20. The 50 is an L, the 20 is 2 X's, and the 5 part of this is just a V. As a number, in Roman numerals, I'm going to have an IV with a bar over it for 4,000. An LXX represents the 70 because that's 50 plus 10 plus 10, which is 70, and the V is going to be a 5. So there aren't going to be any numbers on the test that need a Roman numeral with a bar, but this particular problem, properly, a way to write it is IV LXXV. There probably is another way to write it. If for this part right here, I could have written a V with a bar over it for 5,000, and to the left of it written a C, or an M should I say. That would, to me, say 1,000 less than 5,000, which would be 4,000, and then write the LXXV. That feels wrong to me. I'm not an expert at Roman numerals. This is the way that I intuitively did it. 4 times 1,000 is 4,000. But this would make sense. This would be 1,000 less than 5,000, because anytime you write a smaller number to the left of a bigger number, you subtract. This is 1,000 to the left of 5,000, which would be 4,000. If you wrote either of those on a test, which won't be an issue for me because I'm not going to put something with a bar on the test, but both of those would be okay. So if as you're doing the review, you wrote either of these answers, I'd live with both of them. But there should be no bar Roman numerals on the test. Next problem is converting from bases into base 10. The first problem has 14 base 5, and in order to do this, I start with the first number 4, or the last number 4, multiply it by the base, which is 5, and I start off with a 0 exponent. Then I put a plus sign, and then I take the second number, or the first number really, going backwards, which is 1, and multiply it by the base, and then I increase my exponent from 0 to 1. So this is going to be 4 times 5 to the 0 plus 1 times 5 to the 1. 5 to the 0 is 1, so this is going to be 4 times 1 plus 5 to the 1 is 5, so plus 1 times 5. So this is going to be 4 plus 5. And so 14 base 5 is the same as 9 base 10. I just have to write 9 down for my answer. But 4 base 5 is the same as 9. If I do the same sort of activity for process for B, I'm going to go backwards. I'm going to take the number 6, 1, and 2, which is the number itself going backwards, and multiply it by powers of 7, starting at 7 to the 0 power and working my way up. So the 6, which is in the 1's position, I multiply by 7 to the 0 power. The 1 in the 10's position, I multiply by 7 to the 1st power. The 2 in the 100's position, I multiply by 7 squared. I put a plus sign between each of these. Then I do my math. Exponents first. 7 to the 0 power is 1. 7 to the 1st power is 7. 7 to the 2nd power is 49. So I go 6 times 1 is 6, plus 1 times 7 is 7, plus 2 times 49 is 98, and then I add these numbers. 6 plus 7 is 13, 13 plus 98 is 111, so I would say 216 base 7 is 111 base 10. And again, I really only need the 111 part. I don't need to have the problem written next to the answer, but it's certainly not wrong to do that either. So this is probably moving kind of fast. I know when I'm recording a video that you have the luxury of pausing the video, rewinding the video, so I'm just trying to get everything done the best I can. What I'm going to do for C is write the number backwards. I'm going to take a 1, a 0, which is 1, 0, and then 1, 1, 0, 1, 1. This is just writing the number backwards. Next to each of them, I'm going to write a power of 2. I'm going to start at 2 to the 0 power, then go to 2 to the first power, then go to the 2 to the second power, then 2 to the third power, 2 to the fourth power, 2 to the fifth power, and 2 to the sixth power. And then between each, I'm going to put a plus sign. So I get 1 times 2 to the 0. 2 to the 0 I'm going to replace with 1. 0 times 2 to the 1, 2 to the first power is 2. 1 times 2 squared, 2 squared is 4. 1 times 2 cubed, 2 cubed is 8. 0 times 2 to the fourth, 2 to the fourth is 16. 1 times 2 to the fifth, not that that's readable anymore, but this is 1 times 2 to the fifth, that's 1 times 32. And 1 times 2 to the 6th is 1 times 64, because 2 to the 6th is 64. This says 1 times 32, not that it's readable. Now I do this. 1 times 1 is 1. 0 times 2 is 0. 1 times 4 is 4. 1 times 8 is 8. 0 times 16 is 0. 1 times 32 is 32. 1 times 64 is 64. Then I add all these numbers up. So I'm going to go 1 plus 0 plus 4 plus 8 plus 0 plus 32 plus 64. And that tells me the answer is 109. That technically says that 1101101 base 2 is equal to 109. You just have to have the 109. You don't need the problem next to the answer, but it's not wrong to have the problem next to the answer either. The next few must be going backwards. The next one want me to take a base, something in base 10, and write it in another base. To do that, I look at the base that I'm worried about. Here I'm worried about base 3, and I start thinking about the powers of 3. The powers of 3, 3 to the 0 is 1, 3 to the 1, 3 to the 0 is 1, 3 to the 1 is 3, 3 squared is 9, and 3 cubed is 27. 27 is bigger than 12, so I'm not going to worry about it. My answer is going to have 3 spots in it. So when I go to write my answer, it's going to have 3 numbers. The first number is going to relate to 3 squared, which is 9. The second number is going to relate to 3 to the first power, which is 3. The last number is going to relate to 3 to the 0 power, which is 1. What I do is I start with my number, and I start subtracting. The number I have is 12. I'm going to subtract the biggest power of 3 that's left in it as many times as I can without getting a negative. 12 minus 9 is 3. I've subtracted 1 time. If I subtract again, I'd get a negative. I was only able to subtract 9 1 time, so the first number in my answer base 3 is going to be a 1. Now I go to the next number I'm allowed to subtract. I'm going to start subtracting 3 till I can't subtract 3 anymore. I go 3 minus 3 is 0. If I subtract it again, I'd get a negative, so I can't subtract 3 again. I was only able to subtract 3 1 time. I go to my next number, 1. If I try to subtract 1, I'd get a negative, so I can't subtract 1 at all. So my answer, my problem, 12 in base 3 is going to be 110 base 3. So 12 base 10 is 110 base 3. So to do base conversions into an opposite, a base other than 10. I write down the powers of the base until I get too big. 3 cubed was bigger than 27, so I didn't worry about it. Then I wrote down a spot for each of the powers of 3 that were less than my number, and above the spot, I wrote down how many times I was able to subtract that number. 23b works with base 2, and I wrote the powers of base 2. 2 to the 6th is 64. 2 to the 5th is 32. 2 to the 4th is 16. 2 to the 3rd is 8. 2 squared is 4. 2 to the 1 is 2. 2 to the 0 is 1. And now I'm going to start subtracting as many times as I can. So I'm going to start with 115, and I'm going to subtract 64 as many times as I possibly can. So 115 minus 64, when I do that, I get 51. If I try to subtract 64 again, I get a negative, so I can't subtract 64 again. I was only able to subtract 64 one time. Now I'm going to start subtracting 32 and see how many times I can subtract 32. I subtract 32 once, and I get 19. If I tried to subtract 32 again, I'd get a negative, so I'm done with the 32. I was only able to subtract it once. Now I go to the 16 and start subtracting 16. 19 minus 16 is 3. If I subtract 16 again, I'd get negative, so I can't subtract 16 again. I was only able to subtract 16 one time. The next number I see is 8. If I try to take 3 and subtract 8, I'd get negative. I can't subtract 8, so I'm going to put a 0 for the amount of times I can subtract the 8. The next number is a 4. If I try to subtract 4, 3 minus 4 is negative, so I can't subtract 4. So I put 0 for the number of times I can subtract 4. The next number I see is 2. I'm able to subtract 2. 3 minus 2 is 1. If I subtract 2 again, I'd get negative, so I'm only able to subtract 2 one time. And then I go to the 1. If I subtract it one time, I get 0. If I subtract it again, I go negative, so I was able to subtract the 1 one time. Now I can write my answer. 115 base 10 is going to be 1, 1, 1, 0, 0, 1, 1, base 2. In base 2, the only numbers you're allowed to have are 1 and 0, so this is a reasonable answer for a base 2 number. Hopefully I have one more of these. And I do. So I'm working with base 5, and in order to work with base 5, I write down the powers of 5. 5 to the 4th is 625. 5 to the 5th is bigger than 1643. So I'm going to start subtracting 625. Then I'm going to subtract 5 cubed, which is 125. Then I'm going to subtract 25. Then I'm going to subtract 5. And then I'm going to subtract 1. And eventually, I'll be done. I'll get down to 0. So I start with 1643, and I start subtracting 625. So I'll go 1643 minus 625. I get 1,018. I can still subtract 625 again and not get negative, so I need to. So I'm going to subtract it again. So I'll do 1,018 minus 625, and I get 393. If I tried to subtract 625 again, I'd get negative. I was able to subtract 625 twice, so I'll write a 2 over it. Now I'm going to start subtracting 125. So I'll go 393 minus 125 is 268. I can still subtract 125, so I'll subtract 125 again. 268 minus 125 is 143. Still can subtract 125, so subtract 125 again, and I get 18. If I tried to subtract 125 again, I'd get negative, so I was able to subtract 125 3 times, so I'm going to write that number above the 125. Now I'll go to the 25. If I tried to subtract 25 from 18, I'd get a negative, so I can't subtract 25, so I put 0 for the number of times that I could subtract it. Move my way to my 5. I'll go 18 minus 5 is 13. 13 minus 5 is 8. 8 minus 5 is 3. If I try to subtract 5 again, I'd go negative, so I was able to subtract 5 3 times. So above the 5, I'll put a 3. And now from the 3, I'm going to subtract 1. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. If I subtracted it again, I would go negative. I'm down to 0. I know I have my answer. I was able to subtract 1 3 times. So my answer, 1643, equals to 23033, and I write the base with it. It's in base 5. So to convert from base 10 to base 5, I write down all the powers of the base that are less than my number. I didn't write a 5 to the 5th power down because 5 to the 5th power is over 3,000, which is bigger than 1643. And then I just subtract. I make a spot for every power of the base all the way down to the 0 power, and just write how many times I could subtract. If I can't subtract, I put a 0. Have some unit analysis problems coming up here. I dumped a couple of these because I knew they weren't on the test, and I knew it was going to be a little bit long, and they might have had skills that we didn't quite cover. So problem 24 has a distractor number. It says I went 400 miles on 11 gallons of gas. How many kilometers can I travel? The 11 gallons of gas have nothing to do with my distance. It's how much gas I use. But really, this problem just wants me to change 400 miles to kilometers. So what I'm going to do is I'm going to take the 400 miles that I have, and I'm going to multiply by the unit that relates what I want and what I have. I want to have kilometers, which I'm going to write as km. I have miles, which I can write out as miles, or write as mi, I imagine. So I multiply by a fraction. In the numerator is the unit that I want. In the denominator is the unit that I have. I have miles. I want kilometers. Now I'm multiplying because the 1.6 is in the numerator. So I multiply the 400 times 1.6 and get 640. The units are going to be the kilometers because my miles cancel out. So the answer is 640 kilometers. 25 was not a nice problem because it wants me to make feet into meters, and the units that the author gave me only made yards into meters. So I needed to make 120 feet into yards, and then I could go to meters. This unit wasn't given. I just needed to know that 3 feet was a yard. So I'm going to start off, I'm going to take my 120 feet and change it into yards, because I know that 1 yard is 3 feet. I want yards. I want to get rid of feet. I put feet in the denominator, yards in the numerator. My units when I do this are going to be yards. And because the 3's low and the 120 is high, I divide 120 divided by 3 and get 40. So what I'm really converting is 40 yards to meters. And to convert from yards to meters, I can use that. So I'm going to take the 40 yards that I'm given, or that I forced upon myself, multiply it by a unit, and the numerator is what I want. I want meters, which I'm just going to write with an M, and I have yards, which I'm writing with a YD. My units are going to cancel perfectly. The yards are going to cancel. The units left I'm going to have are meters, and I multiply the 40 and the 0.9 because the 0.9 is in the numerator. And my units are going to be meters. It's not square units, so I'm just going to go 40 times 0.9, and I get 36. The answer for this is that 120 feet is 36 meters, or 40 yards is 36 meters. (26) wants me to make square inches into square feet, and that's a bit tricky. I didn't see a unit that related square inches to square feet, and so for inches, I think of square inches as inches times inches. My goal is to get feet times feet, so what I'm going to do is I'm going to multiply by 2 units. Each unit's going to have the foot that I want divided by the inches that I know. So I know that 1 foot is 12 inches, and I want to go from square inches, so I have inches times inches. I need to be able to cancel 2 inches. To be able to cancel 2 inches, each fraction here cancels out 1 inch, so this inch cancels, that inch cancels. The units that I have left are feet times feet, which is going to be square feet, And what I have to do is go 150 divided by 12 divided by 12 on my calculator to get the numbers. Because the 12s are in the bottom, I have to divide. And I get 1.04 rounded to 2 decimals. So I'm going to write 1.04 for my number. And units are feet times feet, which is feet squared. This is a tricky problem because I didn't have the units that related square inches to square feet. Technically, it's 144 square inches is 1 square foot. If you use that, if you did this and you were clever, you said 150 square inches times 1 square foot is 144 square inches, and you'd get the same answer. That's slicker. That's just making a square inch into a square foot by squaring this and squaring that. 12 times 12 and 1 times 1. Squaring this side, you get 144 square inches. Squaring that side, you get 1 square foot for what that's worth. Problem 27, I changed it to the problem from millimeters to centimeters, and I don't know that that's got updated yet. So depending on when you printed this out, you may have see millimeters here. We didn't have a relation for millimeters to inches, and I didn't teach the metric system to convert from centimeters to millimeters. So if you weren't in a chemistry class, you couldn't do this. So I just went ahead and changed the problem, and I'm going to make 88 centimeters into inches. I found the unit. The unit that I want is inches. The unit that I have is centimeters. So I'm going to take what I have, which is centimeters, put it low, and what I want, put it high. And to do this problem, I have to divide the 88 divided by 2.54. When I divided the 88.24 by 2.54, I got 34.645, and it goes on. This 5 causes me to round that 4 up to a 5, and my units are going to be inches. So for 27, the new version of 27, it's going to be 34.65 inches. It's not square inches, it's just plain inches. Here, the units, centimeters cancel, I'm left with inches. I had to divide because the 2.54 was down low. '28, I also changed this problem slightly because, it needed some metric system changes that we didn't have. And I'll go and change it when I get back to my office, but if you printed it out before I made these changes, then your thing might say liters, kiloliters here. So I want to change 16 gallons of gas to liters, and I'm using the relationship that 1 gallon is 3.8 liters. I'm going to take what I know. I have 16 gallons. I want to change it to liters, so I'm going to multiply by the unit that has what I want in the numerator. What I want is liters, which is just an L if I abbreviate it. Divide it by what I have is gallons. My liters will cancel out, and the 16 and the 3.8, because the 3.8 is not in the bottom, they need to be multiplied. 16 times 3.8 is going to be 60.8, and my units is going to be liters. I could just write an L if I abbreviate the liters, or 60.8. With the word liters is fine as well. 29, I just deleted. I'll delete it. And if you printed it out, and you'll see it, I'm not going to do it. It's something a little bit tricky. And I'm also deleting 31. So depending on when you print this out, you might see a problem 30, but not a problem 29. And you may see a problem 31 that I'm not going to get to. Problem 30 wants me to change 175 pounds to kilograms. Pounds abbreviates LB or LBSs. I'm going to use the unit. In the bottom is what I have. I have pounds. Up top is what I want to get. I want to get kilograms. So the units are going to cancel. I'm going to multiply because the 0.45 is in the numerator. So I go 175 times 0.45. Whoops. 0.45, or just 0.45 without the 0. And I get, in syntax error, 175 times 0.45 is supposed to be 78.75. It's my nice 2 decimals. and the units are kilograms. I could write the word kilograms if I'm not comfortable abbreviating. On the test, you don't need to abbreviate the units if you don't know the abbreviations, but you can abbreviate the units. It doesn't make a big difference to me. I think that's going to be everything on the review. So I'm going to go to my office and upload this video so you can get it on my web page, and change the few problems at the end that I changed, just so you can be working the problems that I work. If you're taking my Math 142 class, the next chapter that we do is a chapter on money. It's chapter 11. I'm not doing anything from the book in chapter 11. I'm doing all via handouts from my webpage, and you absolutely are going to need a TI-83 or TI-84 calculator. And what we're going to use, somewhere on your calculator, you're going to have an apps key, and under apps key it says finance, and we're going to go to that part of the calculator to do everything what we're going to do for chapter 11. So you want a TI-83 or 84 calculator. Some of them, instead of an apps button, have a finance key that's hidden on the calculator, but somewhere your calculator will have the ability to do money problems. That's where the finance feature is. Okay, I hope this worked out well. If you find any mistakes as you watch the video, let me know, and I'll make some sort of posting to let students know that I messed up, because it's really possible that I did.